Alright, welcome to our 8th video of Unit 7. This is our first honors-only video called Salt Hydrolysis. A salt is one of the products of a neutralization reaction. We've discussed this before. For example, most acids and bases will react to form a salt and water, or as a more familiar equation, an acid and a base producing a salt and water. So, salt. A salt made from this way consists of an anion from an acid and a cation from a base. Back in this reaction, we can see that KCl really is consisted of potassium and chloride. The anion, being chloride, comes from our acid, and the cation, potassium, comes from our base. The solutions of many salts are actually neutral, meaning you dissolve them in water, and they form a neutral, some pH around 7. Some salts, actually, that we dissolve are going to be acidic, and some are going to be basic. Salts that produce acidic solutions typically have positive ions that release hydrogen ions into water, meaning a lot of our actual positive ions, our cations, are going to be at least slightly acidic. Now what this means is that almost any time you have a salt with, for example, one of these compounds, this part of it is going to be slightly acidic. Now, the main issue you're going to be dealing with is figuring out what the conjugate acid or conjugate base of something is. So if these are forming acidic solutions, that means their conjugate should be bases. Typically, to find the conjugate of something, you can the conjugate base, you can either add an OH to it, like in this case, forming KOH, or more commonly, you can subtract an H. So either add OH or subtract H. This is a weak base. This is a strong base. That means both these are conjugates of acids. Almost any time you see a positive charge, you can either add a K to it, an H to it, or an OH to it. As a hint to remember it, anytime you've got an alkali metal or an alkaline earth metal, and you see a positive charge, add an OH to it. Those are actually most of our strong bases. Almost any other positive charge, if you know it's come from an acid, just add an H back to it, and you'll figure out actually what it's going to be. I'm sorry, subtract an H from it. So, positive charges, subtract an H. Wow, that's awkward. Salts that produce basic solutions are negative ions that ultimately will attract hydrogen ions from water, thus forming hydroxide. So, cations are typically going to be somewhat acidic. Anions are going to be somewhat basic. When we dealt with cations, we had to deal with whether we add hydrogen, whether we subtract hydrogen or add hydroxide. Most anions that we're dealing with, our job's easy. Just add a hydrogen to it. Whenever you see a negative charge, add a hydrogen to it, you'll get the original acid. So, when we add a hydrogen, we get hydrofluoric acid and hydrochloric acid. Both of these are acids. That means that these conjugates are bases, which means anions typically will be somewhat basic. This process of a salt taking hydrogen from water is called salt hydrolysis. Now that's going back to the negative anions. They are taking electrons basically from water, thus stripping it of one and turning into hydroxide, thus increasing base concentration. That concept is called hydrolysis. Salt hydrolysis, actually. Now, to determine if a salt will produce an acidic or basic solution, you first need to determine whether its original acid was strong or weak. Now, I may not have mentioned this before, so I might as well mention it now. We have 4 main types of acids or bases that we'll be dealing with. We have our strong acids and our strong bases, and we have our weak acids and our weak bases. Now, the conjugate of any acid is going to be some kind of a base, and the conjugate of a base is going to be some kind of acid. However, the strength of that depends on the original strength of the compound. So, a strong acid or a strong base, well, let me show you. They'll form basically a neutral base. Now, it's a compound that is technically a base, but really isn't doing anything. It ends up forming a neutral solution. It's like a really, really, really weak base. Now, not weak as an ionized, just it's not even really worth mentioning being called a base. Okay? However, weak acids and weak bases will form compounds that are also weak. So a weak acid goes to a weak base, and a weak base goes to a weak acid. So, original, conjugate. Now the following is a list of our 7 strong acids. Any other acid is actually going to be considered weak. Most compounds that start with an H are going to be some kind of an acid. So if they start with an H and it's not one of these, it's a weak acid. If it is one of these, it's a strong acid. And yes, by the way, you will have to memorize these. Start now, get some flashcards. The following is a list of our strong bases. Any other base is considered weak. Now these are a lot easier to remember. Any of our group 1 hydroxides or group 2 hydroxides, meaning any metal from our group 1 or group 2 with the corresponding hydroxide shoved on it. Those are the first 2 columns, not including H, because HOH is just water, which technically is an acid and a base. But any of our first column of elements or second column of elements with an OH on it, we are going to be considering those strong bases. Now, lastly, in order to figure out if a salt will form an acidic or basic solution, just remember these rules. If you find that your salt consists of ions that are now basically a strong acid and a strong base, you're going to form a neutral solution. Okay? If you've got, more so actually anytime this happens, strong acid and strong base, or weak base is acidic, weak and strong is basic, weak and weak is neutral. Now I'm actually going to add, not so much add, but a lot of times in salts, you're going to be dealing with basically a salt from a strong acid or a strong base. Now if it's from a strong acid, that means it's now basically a neutral base. So technically we could call it a base, but it's neutral. So it's not actually going to be acting as acidic, it's not even going to be acting as basic, it's just neutral. So if you've got a neutral something with some other base, it's basic. Neutral something with something else that's acidic, acid. So this concept can get a little bit confusing, but really it just comes down to positive charges tend to be acidic, negative charges tend to be basic. How much acidic or basic they are depends on what compound they came from. So, let's try. What type of salt solution will the following salts hydrolyze? So, I'm going to let you work, then I'll put the answers. Keep in mind, you got to deal with what compounds they're coming from. So with that, come back in a bit. Alright, so we have basic, neutral, basic, and acidic. Now, hopefully you're able to figure out what compounds these came from. If not, here's basically what type of compounds they're coming from. Now, keep in mind that how I'm doing this is really what I mentioned before. Potassium's a cation. I add a hydroxide to that, you get potassium hydroxide, strong base. Chloride is an anion. I add H to that, you get hydrochloric acid, strong acid. However, once you set them up like this, it makes figuring it out pretty easy. Strong base and weak acid, basic. Strong base, strong acid, neutral. Strong base, weak acid, basic. Weak base but strong acid, acidic. Hopefully that helps. That's salt hydrolysis. Thanks for watching.